Hey folks, welcome back for another episode of Code Club. In the last episode, I showed you how we could make this Venn diagram using plotting symbols. Yes, this is a scatter plot with 2 points, very big points, but it's a Venn diagram, right? And so this Venn diagram I grabbed from perusing through the articles published in the journal Microbiology Spectrum. I had found this paper exploring pangenomic diversity and CRISPR-Cas evasion potential in jumbophages, a comparative genomics study. I think jumbophages are cool. These are viruses that infect bacteria that have gigantic genomes. I think some of them have genomes bigger than some bacteria. Pretty wild. Anyway, this is published by Sharu Megar. I'm sorry for butchering the pronunciation of these names, and their colleagues. If you come down through this paper and look at their figure 1, you'll see the Venn diagram that I'm trying to duplicate here in R. And so hopefully you'll agree that my effort is pretty similar to theirs. A little bit of styling differences where I put in some commas for thousands breakers, right? And I kind of more evenly space the titles on the 2 circles that you can see here, right? So again, in the last episode when we made this, I made this as 2 plotting symbols. And you can see that last episode to see how I went about doing that. In today's episode, I want to take a different approach, right? So the other approach I want to take is basically using a formula for a circle. And ggplot2 has a really nice geom called geom ribbon. And so geom ribbon, I think of being used to kind of show like a confidence interval around a line or a set of data, right? That you could imagine having this polygon, perhaps a complex polygon, could be a rectangle, maybe a circle, where the area between a minimum and a maximum value are filled in with a color. And so that's what I want to use to generate these circles. And so I'm going to think of this as a more of a formula approach, where we're going to use the formula for a circle to create the y min and the y max values. Here I am in RStudio. I've got the Venn formula.r script. This is basically the same R script I used in the last episode, but if you go down below in the show notes, you can find a link to a blog post for today's episode where you can get the code that I finish with, okay? And so just to kind of do some background thinking here, I know a lot of people get into biology because they hate math. Tough. Get over that, right? So the formula for a circle, we can think of as being x squared plus y squared equaling r squared, right? And so we have x and y and r being the radius, right? And so then we can, if we solve for y, so that we can express y as a function of x, then we'll have, say, y squared equaling r squared minus x squared, right? So again, this is for a circle centered at 0, 0 on the x and y axis. Then we can say y is the square root of r squared minus x squared. So it's going to be a plus or minus, right? Because when you have, say, -2, or if you think about the square root of 4, right? That could be 2, or it could be -2, right? And so the negative is going to get us the bottom surface of the circle, and the positive is the upper, right? So the upper is going to be the y max, the lower is going to be the y min. We could imagine having a set of x values. So we'll have x, and this is going to be a sequence of numbers. Let's go from -r to +r, and let's call this radius to give it a slightly more descriptive title than r. And we'll say radius, let's for now say it's 1. And so if we look at x, that's not what we want. This is a sequence from -1 to 1 by integers, right? But we could say length out, and let's say 100, right? So we're going to create x then to be 100 values between -1 and 1 evenly spaced, okay? And so now we can think about the y upper. So we'll say y upper, and that's going to be the square root of radius squared minus x squared, okay? And then y lower will be the same thing, but we're going to have a minus sign, right? So we're going to have minus the square root. We can now imagine putting this into a tibble where we're going to have x, and we're going to have we're going to repeat x twice because we're going to have the upper and the lower. So we're going to say x, c, x, x, right? And then y, we can say is concatenating together y upper and y lower. So for now, we could say geom point. And I totally, I totally botched this, right? So this should be getting piped to ggplot AES with x and y. So the first two arguments for AES are x and y. And so now you can see that we get a scatter plot of our points, right? And if we were to do something like chord equal, then this is going to make the space on the x-axis the same as the spacing on the y-axis, right? So the distance between 0 and 1 on the x-axis will be the same as the distance between 0 and 1 on the y-axis. And we get a circle, right? And of course, if we increase our resolution, I'll call this resolution. That's 100. And we can plop that in here. We get our circle. And if I were to say up this to 1,000, then we get more points and we perhaps get a nicer circle, right? So instead of thinking about it in terms of points, let's think about it in terms as a line plot. And so that is a line plot. And what's actually happening is geomLine will take the x and y values and it will sort the data by x and then connect the y points. So maybe we can see this a little bit better if I take this down to say 10 on our resolution. So now you can see basically what it's doing. It's sorting the x and it's connecting all the y values. And so then if you increase that resolution to 1,000, there's a lot more back and forth and it's going to look like a solid circle. All right, so let's do 100. And so in contrast to the geomLine, there's also geompath. So geompath doesn't do that initial sort. And so now what we get is a very low resolution circle and we get a line across it, right? So what's happening is it's traversing the positive direction and then it's coming back to x0 before doing the bottom, right? So if we actually in here did combined x and the reverse of x, then that would start with 1 and go back to -1. And there we go. We lose that dividing line across the middle. And if we increase our resolution, we can see a pretty good circle, although over here on the left and right ends, it gets a bit pointy. So if we increase that to say 1,000, then we get a more round shaped circle. You're probably thinking though, but I don't always want my circles centered at 0, 0. So an easy way to deal with that is to come back over to our Tibble and add like the center x value, right? Or we could come to our y and add the center y value. And so back up here, we could do center x equals 2 and center y equals, let's say, -1, right? And so then we can go ahead and run all this and I get a very weird shape. And I notice that I did my plus center x to the reverse rather than to all the x's. And so now putting that plus center x outside of where I created the x vector basically moves the circle over and we see we're positioned at x equals 2 and y equals -1. So again, this is a circle and we're able to draw the outline of a circle. But what we want is the fill of the circle to be a different color. And so what we'll do instead of geompath or geompoint or geomLine is geomRibbon. Okay, and so geomRibbon requires two special aesthetics. It requires a y-min and a y-max. So in our Tibble then, I'm going to modify this quite a bit. So I'm going to have x plus center x because all it cares about is a single x vector. And then y-min, we'll do that as lower plus center y. And I'll go ahead and copy this. And then we'll do y-max. And this will be y upper plus center y. And then we'll feed that into ggplot with geomRibbon. In cutting shortcuts by removing the arguments, I forgot to put in the new arguments. So I'll go ahead and go back to my usual practice of putting in the arguments here for AES. So x equals x, y-min equals y-min, and y-max equals y-max. And so it complained because I have things out of order, right? So the first argument to AES is x, the second expects is y, but I put in y-min. And so because I'm doing things out of order from what we might typically do with like geom point or geom line, then we need to be specific about what column in our tibble here is getting mapped to each aesthetic. Now when we run that, we get a nice black circle. And in here we could do like fill equals red. So we get a nice red circle, right? And then we could do color equals black. And then we get a black border. And I think we could do something like stroke equals 1. So stroke equals 1 is what we did with the plotting symbol, but I think instead we want line width, and that gets us a thicker border. And so if we go up to 2, then we get a big thick line, right? So let's go back to 1. I think the default was probably 0.5. We have one circle of our Venn diagram. And so we could copy this to get the second circle, but that wouldn't be dry. So dry is don't repeat yourself. And so what we have here between, say, lines 11 and 17, I would say is the making of a good function. And so I'm going to create a function with you. I don't think we've made a function here in a long time. So I'll create a function circle, and we'll do function, and we'll do center X, center Y, radius, and then we'll do resolution. So then we'll put our code here in curly braces, tab that over. And by default, the last executed command is what's returned by a function, okay? And so this tibble should get spat out. And so now if I come back here, if I do circle, and then for X center, we do 2, for Y, we do -1, for our radius, we do 1, and our resolution, we do 1000, we should get the same result. We get the same result, right? So I can kind of toggle back and forth here, and we get the same thing, right? I don't imagine that I'm going to want to use a resolution other than 1000. So I'm going to make it a default value. And so what this does is that this then means that by default, the resolution is 1000. And so I can leave out this argument down here then. I've got to load the function after I change it though. Yep, then we get the same thing back, right? So now we have a function to make a circle, but I want another circle, right? And I want to be able to combine those two circles together. And so what you might think about doing would be something like this, where we have two circles, and let's maybe give different X positions. So let's do 0 and 1, so they'll be side by side, and we'll do 0, 0, so 0 on the y-axis, the radius of 1, right? So this will give us a data frame, and then this will give us a data frame for a circle to the right of it. And we can actually bind these two data frames together using the function bind rows, okay? And so that then is a new tibble that has 2000 rows to it, right? And so that's the 1000 from the circle on the left and the 1000 from the circle on the right with our y-min and y-max. And we can then pipe this into the rest of our plot. And whoa, that is wicked. I think what's happening is that we're probably running into something a lot like what we saw with geom line, because we now have these two data frames on top of each other, and there's a region between 0 and 1 where we have the X values duplicated. And so it's kind of going a little bit haywire in there for what is the y-min or the y-max. And so something that we've perhaps seen before with line plots is that we can define the groups, but my circles don't have any grouping information in them. I haven't added a label. And so I'm going to add another argument to my function that I'll call label. So I'll come over here, do label, and by default, I'll make it blank. But in here then, I'll go ahead and do label equals label. And so now I'll have a column coming out of my circle function from that data frame that has a label. And so let's go ahead and run circle. And so now I can put A as the label for the first one and B as the label for the second one. And then when I run this, I see I have A, and I can even pipe this to tail, and I should see the B's, right? Cool. Now what I can do is in my AES mappings, I could go ahead and do group equals label. Now I have two red circles with black borders. Very cool. This is the makings of a Venn diagram, right? We might want to change the fill color. And so remember, the red is set by fill here in geom ribbon. And so here then I could do fill equals label. But if I run it just like this, my colors don't change. And so I need to remove fill equals red here to let the fill color vary based on the label. So now you'll see that I have two differently colored Venn diagrams. So this is pretty close to what we had when we were making the Venn diagram using the plotting symbols. So again, what we're using here is geom ribbon rather than geom point with a plotting symbol or geom path where we drew the border of the circles, right? To clean things up a bit, we could go ahead and remove the legend by doing show.legend equals false. Again, that gets rid of the stuff off to the right. And so now what I want to do is go ahead and bring in some of the other styling that we had from our plotting symbol episode, right? And kind of recapping what we had in the last episode, that we had this tibble, kind of like we have today, much simpler with 2 rows and 3 columns. We don't need that. We don't use the geom point. We had to use annotate point because when we used an alpha with our point, it made the border also have that alpha. So we don't want that. So that reminds me though that we need to go ahead and add alpha to our groups of aesthetics. And we'll do that here with alpha equals label. That then gets on the left basically an alpha of 0, so it's perfectly transparent, and on the right 1, which is perfectly opaque, right? Let's then go ahead and add in our annotation with our text, and I'm going to remove that plus sign so things will run nicely. And now what we see is that our numbers aren't quite in the right place. We need to adjust it. So I think this overlapping spot is going to be 0.5. So we'll do 0.5 there. Maybe the text should be at 0.5 and 1.5. So let's do negative 0.5 and then positive 1.5. So I think those numbers on the left and right do a pretty good job. I can't quite see where this 9296 is falling, if that's in the right place. I think it is. And so I'd like to bring back up our scale alpha discrete. So I'm going to grab this and bring that up here and make sure we've got a plus sign. And so let's do 1 and 0.25 again. I think that placement looks really good. That's nice. And now what we want is the titles across the top. So let's go ahead and start with these expositions for these, and we'll see what that gets us. The X is good. The Y should probably be like, let's make it like 1.1, and it can probably be a bit higher still. So let's do 1.2. So I think that's good. But now, of course, our labels are too far over to the left, and they're also getting clipped at the top. I want to try adjusting the vertical aspect. So if we do vjust, I think 0 is at the bottom. So basically the data will be, the bottom of the text will be at the Y coordinate of 1.2. So let's try 0. And if it's 1, I think it's at the top. Yeah, so that's the bottom there is at 1.2. So let's make this vjust equals 1. And so then that puts the top of this at 1.2. I like that, but let's go up a bit to like say 1.3. That's good. And then let's move both of these over to the right a bit. And so maybe instead of 0.75, let's go ahead and do negative 0.5. So it's going to be centered at negative 0.5. And then we could also do 1.5 on the right. And I think that is pretty good placement. Maybe things could moved up just a smidge. Let's do 1.4. Yeah, I like that. That looks pretty good. And now we can start bringing other things back in. We don't need this chord Cartesian because we've got the chord equal. And in fact, I'm going to try to bring some organization to this mess and replace chord Cartesian with chord equal. I don't need to change the X and Y limits. I think that's fine. Also before in chord Cartesian, we turned off the expansion. I'm not going to worry about that because I think we're going to have a pretty nice border around it. We then had scale fill manual to change the colors. And so let's incorporate that. And I think I need a plus sign up here on line 37. So then we've got our colors that match pretty well. I've got another scale up here, the scale alpha. I'm going to move that down. I like to have all my my scales and my geoms all together, right? That way, if I'm looking to modify the appearance of something, I kind of know where the functions are, right? Like I know all my geoms are up here, my annotations are together, my coordinate stuff's together, my scales together, and then my theme stuff is down here at the bottom. And so then let's go ahead and run this whole thing and see what we get. Very cool. I think that looks really nice. I do think we have a black border around our figure. So let me see if that shows up in the outputted file. So yeah, that black border is showing up. I think what I want to do is come back to my plot background element rect, and we can do color equals NA, and that should remove that border color. Very good. So I think this is a pretty good alternative approach to generating these Venn diagrams, to using the plotting symbol. So on the left is using the circle approach of defining a circle function, and the right is using the plotting symbol. Again, they look very similar to each other. I think using the formula for having to come up with the formula was actually a lot easier to work with than these plotting symbols. You'll recall that with the plotting symbols, trying to figure out like the right size of the plotting symbol varied by how close the circles were to each other, and there was just a lot of moving things around. Whereas drawing the circles with that function made things a lot simpler. At the end of the day, we get the same figure, and I think that looks a lot like what was in the original paper. I think maybe here the line stroke is a little bit thicker than what I had from the plotting symbol, but who cares? I think it's really cool that we can do things by different approaches in R and get the same result. Hopefully you agree that that's kind of a cool thing. I know it frustrates some people because they want to know what is the right way to do this. But the reality is that there's many right ways to do the same thing. And again, by playing with these tools, even if they're not figures that you make on a regular basis or using techniques that you're regularly using, by getting practice with it, when that need arises, when you do need to make a Venn diagram, or when you do need to kind of do some type of drawing activity like we've done here instead of plotting data like for a scatter plot, you'll be better prepared to do that. All right. Well, I hope you've enjoyed this adventure into Venn diagrams, both using the plotting symbols as well as using functions to draw circles. Please make sure that you've subscribed to the channel, and I'll see you next time for another episode of Code Club.